Okay, in our next example, what I want to do is let's look at the set of polynomials. So in our case, let's just look at P2. This is going to be the set of polynomials of degree at most 2. So here, A, B, and C are real numbers. And we're looking at the set of polynomials ax squared plus bx plus c. This is a vector space, as we've talked about. Let's consider the vectors. So let's consider the span of the vectors, let's say x and x squared plus 1. And so I want to know, really, is this all of P2? Is it not? Is it some subspace? Is it not a subspace? And it turns out that this is going to be the set of vectors of the form, and I used A, B, and C here, which is fine. Let me slightly change my mind here. So let's call this C1, C2, C3, where C1, C2, and C3 are real numbers. And so the span of these two sets is going to be the set of linear combinations. It's going to be ax plus b times x squared plus 1, where a and b are real numbers, such that a and b are real. Now this is not going to be all of P2, because this is only going to include the polynomials where the coefficient for the x squared term is going to be the same as the coefficient for the constant term. So for example, this does not include things like 2x squared plus 3x plus 1, because the coefficients for the x squared and the 1 term are not the same. So this is not all of P2. I will let you determine whether or not this is a subspace. Here's a hint. This is a subspace. Spoiler alert. Okay, prove it. Try and justify that. Why is this a subspace? Okay.